I'd like to thank Giulia Sarzana and Biogas Italy for inviting me to make a presentation at the conference on climate change with specific reference to the theme of soil carbon sequestration and food security. I appreciate the opportunity to talk to you on this important topic. The global issues of the 21st century include population of 7.8 billion and increasing at the rate of 1.14% or 7.25 million per month. Per capita arable land area of 0.2 hectare and decreasing to less than 0.07 hectare for 30 countries by 2025. Soil degradation already affecting 2 billion hectare and increasing at the rate of 5 to 10 million hectare per year. A renewable freshwater supply of less than 1,000 cubic meter per 30 countries and increasing to 58 countries or 4 billion people affected by water scarcity by 2050. Atmospheric concentration of CO2 of 411 parts per million and increasing by about 2 parts per million per year. Energy use of 575 quads in 2015 and increasing by 8 quads or 2.2% per year, projected to be 736 quads by 2040. Per capita grain consumption of 300 kilogram per year, but decreasing with the increase in population. Food insecure population of 820 million and unfortunately increasing in the year 2017 and 2018. The per capita CO2 emission in the world of 4.9 megagram of CO2 per year compared with that of the United States of almost 18 megagram of CO2 per year. And finally, the humanity's water footprint at a global level of 1,358 cubic meter per year and increasing in spite of the decrease in renewable water resources at a global scale. All these 10 issues have one thing in common, and that is that in part, the solution to these issues lies in sustainable management of world soil resources. Unfortunately, the UN Millennium Development Goals were not fully realized, and that raises the question, what might be the fate of sustainable development goals if the soil resources continue to keep decreasing? At the same time, the resources used for agriculture include 49% of Earth's terrestrial surface used for agriculture production, 77% of agricultural land, almost 4 billion hectare allocated to raising animals, 70% of global freshwater withdrawals used for irrigation, 30 to 35% of global greenhouse gas emissions contributed by agriculture, and yet 1 in 9 person is food insecure, and 2 to 3 in 7 are malnourished. Therefore, how do you meet the food demand of the world? And the world produces enough food to feed already 10 billion people. Thus, the food and nutritional security at a global scale must be achieved by reducing waste, which is about 30 to 50%, increasing access to food by addressing poverty, inequality, wars, and political instability, improving distribution of food, increasing use of plant-based diet such as pulses, legumes, and maybe artificial hamburgers, including other sources of protein, and accepting personal responsibility of not taking food and natural resources for granted while increasing productivity from existing lands, restoring degraded lands, enhancing biological nitrogen fixation by legumes, and converting some agricultural land back to nature for nature conservancy without any new conversion of natural land to agroecosystem through eco-sustainable intensification and restoration of soil health. Sustainable intensification and restoration of soil health are the key strategies. But making sure that no additional appropriation of land and water to agriculture. Therefore, this eco-intensification, what does it mean? It implies the strategy to produce more food from less land, from less water consumption, from less input of fertilizers and pesticides, from less use of energy, and specifically from less emission of greenhouse gases per unit production. Producing more from less, that's the goal. Reducing the use of inputs and using C and PK, the strategy of increasing carbon in soil along with the inputs of NPK, rather than simply increasing the use of NPK or chemical fertilizers. The idea of C means increasing inputs of carbon into the soil with the goal of creating a positive carbon budget. Therefore, the gains of carbon into the soil by practices such as biochar, compost, cover crop, root biomass crop residues must always exceed the site-specific losses by erosion, leaching, and decomposition. This would lead to carbon sequestration in soil compared with the situation where the inputs of carbon is less than the losses, and that is unfortunately the case in most developing countries, especially in sub-Saharan Africa and South Asia and elsewhere in the Caribbean and Central America, where the carbon stock in soils are continuously decreasing. If we increase the carbon stock by 1 ton of carbon per hectare, all other factors remaining the same, the crop yield of corn can be increased by 100 to 300 kilogram per hectare, soybean by 20 to 50, wheat by 20 to 70, rice 10 to 50, sorghum 80 to 150, millet 30 to 70, and beans, pulses, grain legumes by 30 to 60. In total, increasing carbon stock in cropland soils of the world can increase production of 30 to 50 million tons of food grain just in developing countries alone. Increasing by 5 or 10 megagram of carbon on arable land per hectare basis can have a drastic impact not only on the total production, but also the nutritional quality of the food produced. The no-till farming or conservation agriculture, here example from West Africa of my own experiments since 1971. This practice need to be adopted throughout the developing countries, especially in sub-Saharan Africa and South Asia. Here is an example. If the crop residues are removed for traditional biofuel, such as burning for cooking and processing, or heating homes, or using for other purposes such as building fences and thatches, the plot in the forefront is where the crop residue have been removed consistently for 15 years from 1972 to 87. This was in West Africa, Nigeria. The plot in the background is where the crop residues were left intact on the soil as a surface mulch, which leads to improvement in soil carbon concentration stock and the biotic activities of earthworm, termites, and of course, especially microorganisms. The soil biota, which require the crop residue input, is the bio-engine of the earth. And in that context, there is no such thing as a free biofuel from crop residues. We must make sure that the crop residue removal from land for biofuel production, such as cellulosic ethanol, is not done in a way that hinders or that destroys or that has adverse impact on soil health and its functionality. Drought of 2012 in Midwest United States was a very good example to look at the impact of crop residue on production. Here is an example where for last 8 years the residue had been removed and the corn growth and its productivity was extremely low compared with a few meters away plot where the crop residues were maintained. Therefore, the soil health, soil quality, available water reserve, the green water supply were much better. And that is what essentially climate resilient agro-ecosystems are. Conservation agriculture with crop residue mulch. If we did recommended management practices, the cereal production between 2005 and 2100, which is required total of about 3,540 million tons by 2100, compared with 2 million tons at the moment, billion tons. I'm talking about 2,000 million tons or 2 billion tons, can be achieved from a land area which right now is about 620 or so million hectare to about 500 million hectare by 2100. Fertilizer use, nitrogen, which may be about 200 million tons at the moment and can be decreased about 100, while the kilogram per hectare production or the yield can be increased almost double or more than double from 3,300 to 7,000. So the idea is to reduce the land area, increase the total production, increase the per hectare yield, reduce the use of fertilizers and pesticides, and yet improve soil functionality by improving soil organic carbon concentration and soil health. This is the goal, that the strategy of producing more from less. The idea is use the best and save the rest of the land. Sustainable development goals of the Agenda 2030 also depend on soil health, such as goal number 2, number 13, and number 15, ending hunger, climate action, and life on land. At the same time, other goals such as ending poverty, good health, and clean water, along with renewable energy, also require the restoration of soil health through soil carbon sequestration. Finally, I would like to mention that if I'm asked what I would suggest to reverse degradation and restore the environment while ending global hunger and advancing sustainable development goals, the logical response would be to change the ways soils are taken for granted. A prudent strategy would imply making soil and agriculture an integral part of the solution to adapting and mitigating climate change, and encouraging farmers and land managers to restore degraded and desertified soils, afforest the denuded lands, reduce degradation and waste of natural resources, enhance the eco-efficiencies of input, and save soil and water, both for human well-being and nature conservancy. I emphasize saving the land and water for nature conservancy. I wish you all an excellent conference and thank you for the opportunity to talk to you.